Welcome to EDU World Space.
Problem 3.115. In this problem, we have to calculate the value of M for which the equivalent force system must pass through the point A in first part. In second part, the equivalent force should pass through the point B, and in third part, we have to find the value of M for which the equivalent force passes through the point C or at point C. So for going to solve this, before starting this problem, we have to calculate the equivalent force that is acting on the system, and that can be found by writing it in vector form. So by considering this direction to be x-axis, that is the parallel to the axis, that is parallel to the side AB, this is x-axis, and perpendicular to the AB or parallel to BC, this will be y-axis. So we can write all the forces in I cap and j cap component as this 10 pound force is in minus j cap, so this will be minus 10 j cap. This 25 will have component in x and y axis as plus 25 cos 60 I cap plus 25 sin 60 j cap. This 30 pound force is in negative x axis, so minus 40 I cap. If we collect the coefficients of I cap and j cap, it comes out to be minus 27.5 I cap plus 11.65 j cap. So now we have got the equivalent force that is acting on the system. Now according to the problem statement of part A, the equivalent force system or equivalent force must pass through the point A. Let's say this was the point A, this is point B, and this is point C. So if equivalent force is present at point A, so we can draw the force vector here as this component will be 11.65 pound and the horizontal component will be 27.5 pound. Now since both of these are equivalent system, so moment about any point should be same. So if we calculate moment about point B in actual diagram, so we can write it as moment about point B in actual diagram considering the anti-clockwise direction to be positive. So this comes out to be, this M is already in anti-clockwise direction, so this will be M, and this 10 pound force will cause an anti-clockwise couple, so this will be plus 10 multiplied by 12. This 25 pound will have no effect, so plus 0, and this 40 pound is going to cause a clockwise couple, so this will be minus 40 multiplied by perpendicular distance, that is 8, and this moment value, that is about point B in actual system, must be equal to the moment value in the equivalent system. Now this AB distance is given in the problem as 12 inches, so moment in equivalent system will be this 25.7 pound force will have zero moment since its line of action is passing through the point B, and this 11.65 pound force will have moment 11.65 multiplied by 12. So if we solve this, the value of M comes out to be 60.2 pound inch. It means that if positive value is coming here, it means that our moment is in anti-clockwise direction. Now in second part, they are asking that what should be the moment value so that the equivalent force is present at point B. So this is A, B and C. If equivalent force is present at point B, so we can draw here the equivalent force as this component 11.65 pound and this was 27.5 pound. Now if we calculate moment in equivalent system about the point B, so it will be 0 since both of these force lines are passing through the point B. So just we have calculated here the moment about point B in actual system as this amount, so this entire should be equal to the moment about point B in equivalent system in second case, and in second case moment about the point B because of these equivalent forces are 0. So we can say that moment about point B in actual system was m plus 10 multiplied by 12 plus 0 minus 40 multiplied by 8, and this must be equals to 0. So if we solve this, m comes out to be 200 pound-inch. Again, the value is positive. It means that anti-clockwise direction that we had assumed here was true. Alright, so this is the moment value in second case. Now in third case, they are asking that what should be the value of m for which the equivalent force system is present at point C. So this is A, this was point B, and this was point C, and we can draw here the equivalent force at point C as, in this direction, this was 11.65 pound, and in x direction it was 27.5 pound. So if we calculate the moment here, this vertical distance is given in the problem as 8 inches. So moment in equivalent system can be written as about point B will be, since this 11.65 pound will have zero effect since it is passing through the point B, the only moment will be because of this 27.5 pound force, and this is acting in, this will cause a clockwise couple. So this will be minus 27.5 multiplied by perpendicular distance, that is 8, and this must be equals to the equivalent moment in actual diagram, and we had just here calculated the equivalent moment in actual diagram. So we can equate these two values as m plus 10 multiplied by 12 minus 40 multiplied by 8. So here the only unknown is m. So if we calculate this, m comes out to be minus 20 pound-inch. So what does this minus sign indicates? It indicates that the moment that is acting at end A is 20 pound-inch in clockwise direction. Means here in first part and second part, the moment direction should be counterclockwise, but in third part moment direction should be clockwise direction.